I'll be talking now about technology in the extractive industry. I'll be covering oil, gas, and the solid mineral sector. The extractive industry is very much technology advanced. For example, in the extractive industry today, automation is happening everywhere. Big data is part of a modern mining today, where from remote locations, you have smart people operating sophisticated software with a view to, for example, laying explosives, managing logistics. Several reasons pushing technological advances in the extractive industry. Some of them are intrinsic to the extractive industry. This arises of the fact that now we are mining much more complex ore deposits with complicated mineralogy, which require new mineral processing techniques. We are also mining ores which have lower grades. Again, this requires new techniques. In addition, we are going into completely new environments. The space. Companies are already investing and deploying technology with a view to making mining of asteroids economically viable. We are equally mining in deep sea environments, the Arctic, in the so-called pre-salt. These are in depths in excess of 2,000 meters or so, and that, of course, requires a completely different set of technology. Environmental concerns also are pushing the mining industry towards, or the extractive industry in general, towards embracing technologies which are more environmental friendly. Climate change is, again, a very important issue to consider in terms of reducing the carbon footprint. So the introduction of new technology in the extractive industry can have, of course, significant benefits in terms of resource efficiency and material stewardship. That is, we have to reduce the level and the quantity of materials that we use in the production process. But at the same time, it can have negative social impacts. For example, in South Africa, labor union, organized labor, has been fighting automation in deep mines because of concerns with employment. This is one of many issues that technology may trigger. Let me go back to the basics. Why deep sea mining? First, as we've mentioned earlier, we are now in terrestrial terrains mining ores which are low grade, which are very difficult to access. Yet, in marine environments, we have very significant concentrations of highly graded mineral resources. We are talking of manganese nodules. We are talking of phosphorites and other minerals. So there is an economic imperative behind going into deep sea environments. However, it's an area that requires careful management because, amongst other factors, the environmental impacts. We are talking of very fragile environments, some of which are not very well understood. Another important dimension on any conversation about deep sea mining has to do with international governance architecture, especially in the so-called high seas. These are international public goods, and yet access to mineral resources in the deep sea environment is now governed essentially on your ability to access advanced technology. So you are therefore before a serious issue here where an international public good, which would in principle have to benefit the entire humanity, is being governed, access to its resources being governed by your ability to access technology. Of course, you have the International Seabed Authority, whose role and function is to regulate access rights, mining, extraction of deep sea resources globally. However, there are issues there in terms of benefit sharing that are not yet clearly articulated. Fracking involves the blasting of huge amounts of water, sand, and chemicals deep into underground rock formations to access valuable oil and natural gas. This has been made possible because of new technologies. In this case, we are talking of horizontal drilling. It involves also the addition of chemicals with a view to dissolving materials that are in those fractures. So essentially, many sandstones, limestones, and shales contain natural gas whose access can be increased if you are able to release the gas that is contained in those sediments. One of the major problems with hydraulic fracturing has to do with the amount of water that is required for you to be able to fracture this rock and sediment formations. And the contamination of underground water that can result because of the introduction of chemicals. So environmental concerns are indeed a major issue. Hydraulic fracturing became economically viable when oil and gas prices were historically very high. You would recall that oil prices reached $100 a barrel, which of course made these projects economically viable. Now, especially since 2014, oil prices have gone down, and that have impacted the business model that made hydraulic fracturing possible. Tar sands are a new frontier in mining. We are talking of what we call bituminous sands. These are heavy oils that are in sandstones, shales, and other rock formations. This type of oil is available in many places in the world, but the most famous locations are in North Canada, Alberta, to be more specific. The major concerns here are to do, again, with environmental impacts, because in addition to having to clear the overburden, accessing tar sands requires also the need to hit these shales with a view to liberating its resources. And the hitting of the shales contributes to climate change with, of course, greater carbon footprinting. In addition to that, transportation of tar sands also is complicated, and it can create a footprint of contamination across the entire transport route. I would like now to talk about drilling in the Arctic. And I'm sure you'd ask me, why are you talking about this? The main reasons are the following. First, this is a pristine environment where you have a unique combination of unique biodiversity and an area which has not yet been made accessible to the humankind. And unfortunately, because of climate change, the rise in temperature, this has now been made possible. In addition to that, there is better technologies now to map these terrains. You can use airborne and remote sensing techniques that have greater penetration and ability to read in even in environments where you have this ice cover. So those are part of the reasons that, technologically speaking, that have made this possible. I would also like to talk about ultra deep, and you would ask me, what is the difference between deep sea mining and ultra deep drilling, for example? Well, essentially, deep sea mining, we are talking about solid minerals. I've mentioned earlier manganese nodules, phosphorite, and so on and so forth. While with ultra deep, we are talking about accessing oil and gas resources, which are in depths in excess of 1,500 meters. There are major developments there. We have what we call the flammable ice. Those are methane hydrates. Essentially, that is methane which is captured in ice cubes, which the Japanese have now cracked the technology to access this. And it is potentially a game changer because the resources are significant. However, as with most of these fragile environments, we have serious issues in terms of its environmental impacts. And in the particular case of the methane hydrates, heating them would significantly contribute, or would contribute significantly to global warming. The last frontier in terms of extraction that I would like to discuss today is the deep salt. The deep salt is a geological formation that was formed, for lack of a better word, when the Gondwana supercontinent broke. These were the days when Africa and South America were glued together. So through plate tectonics, those two continents separated, and before the salt formations were deposited, you had what we call the pre-salt. The pre-salt had significant accumulations of oil and gas, which are now being commercially exploited, especially in places like Brazil and Angola, the two opposite countries in this super continent, the Gondwana continent. So the pre-salt environment is essentially a deep sea environment where technology, deep sea drilling have made it possible. But where again we are faced with the same kinds of concerns, the environmental impacts of accessing these environments which are not very well understood yet. As you've noted through this brief introduction in the impacts of technology in the extractive industry, we are accessing more and more and different types of environments. This, of course, would make the cost of accessing the resource perhaps cheaper. But at the same time, we have to be mindful of the impacts that accessing fragile environments create, and some of them could be irreversible.